Hi students, welcome to SPR IAS EduTech. Today you're gonna see about an article which is present in the news as a UPSC flash news explained. So here you're gonna see about a South Korea superconductor paper. So in internet, South Korean researchers has published a paper on superconductivity. So and which can be for the material that can function at a room temperature. Now you need to understand what is this superconductivity, and again what is this, how it is acting it on a room temperatures. So here multiple questions rise in your brain, everything will be answered by me clearly. So before that you need to understand this paper is very important for your GS paper 3 and science and technologies. For more updates you can keep watching, and also if you want the PDF of the content that I'm teaching here, you can join the Telegram group that is provided in the description. Yeah, so you're gonna understand about the news that is about a room temperature superconductivity. Now let me tell you what is this superconductivity. This is one thing you need to be clear enough. So first, superconductivity means what? So here superconductivity is a feature where you can observe a zero resistance to the electric current. So which means at which position it is at a absolute zero. Absolute zero means it is 273.15 degrees Celsius minus, which means 0 degree Kelvin or minus 273, that is considered as to be an absolute zero. So at that position a material will be exhibiting the superconductivity where a zero resistance. Zero resistance regarding what? So regarding the electric flow without a loss. So if you are having zero resistance, then the electricity will flow without any loss. And also here superconductivity is a feature which also exhibit the perfect diamagnetism. What is this perfect diamagnetism? Diamagnetism is a strong repulsion of the magnetic field. So here the material will be repelling the magnetic field very strongly. That is what called as a perfect diamagnetism, which is observed in the superconductivity. And next here, this happens at a critical temperature, which means above the critical temperature the material that you are taking will be acting as a normal, which means behaves a normal, which means below the critical temperature it will be behaving as a superconductor. Superconductivity will be exhibited at certain temperature or below certain temperature, that is absolute zero. Now combining this perfect magnetism and critical temperature, you need to understand one more element or one more concept called as the Meissner effect. What is it called as the Meissner effect? What is Meissner effect? So here you know that diamagnetism means it is repelling the superconductivity. A superconductor will repel away all the magnetic field at a critical temperature. So here from normal to so-called superconductivity, it will be transforming. So the transforming to superconductivity state by expulsion of the magnetic field. This process or this effect which is happening in the superconductor is called as a Meissner effect. You're clear with this now? So what is the importance of this superconductivity? Now I understood what is the superconductivity. Now I need to tell you what is the importance of this superconductivity. What may be the better qualities that is required for this superconductivity? Yeah, so here you know the electricity, the current will flow. What is current? It is a flow of a charged particles, which means electrons flow in a certain direction, that is called as the superconductivity. Or sorry, the electrons flow in certain direction, it is called as a current. So current means you know that. So when current flows, the electrons will be flowing. The electrons flows in a material. So in the material it will collide with the atoms present in the material. So whenever these electrons collide with the atoms present in the material, it will offer a resistance. So which means it creates a resistance. So the energy is lost in the form of heat. So when the energy is lost, it's a big problem. So here superconductor will overcome this issue. So here in superconductor, electric resistance is zero, the energy loss will be also zero. So it has a more efficiency in day-to-day life. So now let us understand what are all the uses of it and where we use regularly. If you come to it, the uses of the superconductor or superconductivity, here you can see familiarly it is used in MRI scans and also super fast maglev trains. Maglev trains means it will be floating above the tracks, which means it will not lie on the tracks, it will be floating above the tracks. It is taking the feature of superconductivity and magnetic field and these things, and it moves very much faster. And next here if you learn about the examples, which means what are all the materials that exhibit superconductivity. If you come to the examples of the material, first they had detected a material named mercury which can exhibit a superconductivity at absolute 0 or minus 273 degrees Celsius. And other elements that exhibit the superconductivity are lead, aluminium, tin, niobium. These are all the important things. And next, what is in the news in a recent time? If you study it, the news is about a material called as LK99. What is this LK99? What is the importance of this LK99? If you read it, so it is the published in the Korea, researchers has published in a news or internet that, so here this LK99 can act as a superconductor or can exhibit superconductivity at just a room temperature, which means it can conduct superconductivity at room temperature. Actually, it is not possible in room temperature because it needs high cooling effect and other things. But now they are creating such elements which can be more efficient. How it is synthesis? For the synthesis of this material, they use a baking process, which means lanthanide and copper phosphide. They use two elements, that is a baking process of lanthanide and copper phosphate, so which will exhibit the superconductivity at normal air pressure and room temperature also, and it can also exhibit the superconductivity till the temperature of 127 degrees. So this is the extraordinary feature of this LK99 which was discussed. So if it is being implemented in coming stages in future, it can change drastically. It can bring such a great improvement that they were telling in this article. So this article stands to be very important for your science and technology preparation and also UPSC preparation. For more articles like this, kindly keep following me. That's me, SPR.